This is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as Runoff Potential Indices of Watershed. So till now in the previous lectures we have discussed about runoff rainfall relationship. So what is the rainfall and runoff relationship and how it is totally dependent on different factors. So based on that factors, the runoff will be decided whether the runoff is more or the runoff is less. So most of the factors, like we have the factors like type of the soil, type of the topography and type of the area, that all depends type of the rainfall, whether high intensity rainfall is there or low intensity rainfall is there, that all depends the runoff amount, whether it is more or less. So today we'll be discussing about the runoff potential indices of watershed. So what is watershed? First of all, let us understand. So watershed is the area which is covered with a lot of streams will be flowing together through runoff, and it will collect to a single outlet, to a single point from the different locations. The flow will come and it will just collect to a single point. Like watershed will be like different streams will be there from all the areas, and finally it will be collected to a common outlet. So this common outlet, we call it as watershed. So common outlet is a watershed. So this watershed, which places it is required, the conservation of the water is required, and which places are called as watershed. How does the watershed management practices can be followed based on this runoff relationship. So first of all, runoff potential indices means what kind of runoff is occurring, whether it is based on the high intensity rainfall or based on the low intensity rainfall, that all we are going to learn today. So in the introduction part we are going to understand. So runoff potential indices of watershed are important for understanding and high predicting how much rainfall which will result in the surface runoff, which can affect the flood risk zones and which will affect the soil erosion and the water quality. So first of all, runoff potential of the watersheds are important for understanding to predict the rainfall. Prediction of the rainfall is important. So prediction of the rainfall. So the prediction of the rainfall can be done with the help of this runoff potential indices, which will result in the surface runoff, and it will tell us about how much area is affected, how much area is under the flood risk, and how much area is under the soil erosion. So these three things, soil erosion and water quality, this totally depends on the runoff potential. So a runoff potential, if it is runoff is more, then the soil erosion will definitely take place. So such places where the vegetation, where the forest areas are very less, that areas there is no areas where the water can hold. So whenever a rainfall occur, if there is a less forest area, if there is a deforestation in such areas, so the water holding capacity will be less. So there is no areas where the water can be holded over there, and erosion will take place. Lot of erosion will take place. And the second thing here is there is a chance of flood risk. How there is a chance of flood risk? Because from the slope area to the lower line area, so this is the slope area and this is the lower line area. So slope area and lower line area, what is the difference here is, so whenever the rainfall occurs, so in the slope area it falls, the rainfall runoff will be more. So the runoff is more here, and when it comes to the lower line area, so what will happen, the runoff will be less and the seepage of the water will be more. So here the groundwater quality will be better compared to this areas. The hilly areas, the runoff is more, and when it comes to the lower line area, the runoff is less. So the flood risk will occur and the soil erosion will occur. Where the flood risk will occur here is in the lower line areas, flood risk is more. Why the flood risk is more? Because all the water will just flow from the top hill and it will just accumulate in the flat areas. So this is how the water will be, the areas will be under the risk conditions. So we will just see through this mapping and see the rainfall areas wherever the rainfall and runoff relation is there. Based on that, we can just try to understand which areas are under the vulnerable areas, which areas are under the flood risk zone, and which areas are under the soil erosion zone. Soil erosion will take place due to the high intensity of the rainfall. If the high intensity of the rainfall is more, then what happens? The water will be in such a manner that it will just remove the top layer of the soil. So how it will remove the top layer of the soil? Because it will wash away based on the slope, the intensity. If it is more, it will wash away the entire top layer of the soil, and then the soil erosion occurs. And the water quality, how it is affected is like, wherever you see the lower lying areas, all the debris and all the top layer of the soil and lot of pollutants which will accumulate on the surface of the ground, wherever it will accumulate, it will directly, the water will be seeping inside the ground, taking this all contaminants. The water quality will be affected in such areas. So several factors influence the runoff potential of the watershed, and these often incorporated into the indices or models. So here are some common used in indices and factors. What we are using here is, first of all, we have one curve number. So what is curve number? So under this curve number, it is developed by USDA Natural Resource Conservation Services. So this curve number is developed by USDA, that is Natural Resource Conservation Services. And the curve number is widely used in the index that reflects the potential for the runoff in a given area based on the land use and the soil type and the antecedent moisture conditions. So this runoff will be totally decided based on the soil conditions. If the soil is a sandy soil, there the runoff will not take place, the runoff will be less. Why? Because it is having the capability of just absorbing the water under that. So wherever the sandy soil will be more, that areas will not be affected with the runoff. So here the potential runoff areas based on the land use, soil type. So land use is what? Land use is also one of the important factor here which will affect the runoff relationship. So wherever the land use pattern, if you see the more concrete structures will be there the runoff will be more. Why? Because there is no place where the water can hold. So whenever the rainfall occurs, the total flow of water will take place and it will flow away from such places and settle down to the plain areas. Now these factors which determines the curve number value here. So the curve number is dimensionless parameter which indicates the runoff response characteristics of the drainage basin. So in the curve number method, this parameter is related to the land use, land treatment and hydrological condition, hydrological soil group and antecedent soil moisture conditions in the drainage basin. So curve number method, it is a parameter which will help us to relate the land use. It will help us to relate the land use, it will help us to land treatment, it will help us in hydrological conditions, it will help us in the hydrological soil group and antecedent soil moisture conditions. Now let us understand one by one. So what is land use and land covers? So as we have discussed many times in the previous lecture, so what is land use? Land use is the area which is utilized by the human, which is utilized by the anthropogenic activities like the buildings, the constructed area, the transportation area, the areas where the dam is constructed, that areas are the under the agriculture, that all areas are under the land use pattern. Now land use represents the surface conditions in the drainage basins and it relates to the degree of the cover. Now in the SCS method, the following categories are distinguished. So like if you talk about the land use, so in this we have the following categories like fallow is the agricultural land used with the highest potential for runoff because the land is kept bare. So now if in this condition, if the land is fallow land, what is a fallow land? Fallow land means it doesn't have, fallow land means the empty land. You can say empty land. So there is no crop grown in that, there is no agriculture which is grown in that. So that kind of fallow land will be totally affected by the runoff because there is no place, there is no type of vegetation, there is no vegetation there which will just hold the water over there. So fallow is the agricultural land use with the highest potential for runoff because the land is kept bare. Once the land is kept bare, that means the fallow land it is unable to hold the water. So row crops are field crops planted in the rows far enough apart that most of the soil surface is directly exposed to sunlight. So most of the parts will be directly exposed to the sunlight. Row crops means the crops which are planted in a row. Like this, how the plants will be grown. So this will be grown like this in one row. This will be grown in the other row, third row. This type of rows are there. So in this row, the crops will be grown. So in this row, the crops will be grown and the planted in the rows far enough to apart the most of the soil surface directly exposed to the sunlight. Now small grain is planted in the rows close enough that the soil surface is not directly exposed to the sunlight. Small grains like which is planted in rows, it is very close enough to the soil and surface is not directly exposed to the sunlight. So this is the conditions in the land use and land cover. Now, if you talk about the other factor or other parameter like treatment or practice in relation to the hydrological conditions. So, land treatment applies mainly to agriculture land uses. It includes the mechanical practices such as countering or terracing and management practices such as rotation of crops, grazing control or burning. So land treatment applies mainly in the field of agricultural land uses. It also includes in the mechanical practices such as countering and terracing. Like in the hilly areas, there this type of practices are going on. Wherever we see the hilly areas, this countering and terracing practices are going on. And the management practices such as rotation of the crop rotation is also going on. Grazing control or the burning of the forest. Burning of the forest means to just do the agricultural practices, the burning, slash and burn activities, the slash and burn activities are going on by the human beings, and grazing control to be done in this kind of activity. For grazing control and burning pasture range and the woodlands, the hydrological conditions is classified as poor, fair or good. So when you talk about this control and burning conditions of the grazing, the hydrological conditions are classified as either poor, either fair or either good. Now hydrological soil group. So what is hydrological soil group? Soil properties greatly influence the amount of runoff. Soil properties, what are the soil properties? Soil is having a different properties like color of the soil, texture of the soil, like moisture content in the soil, and physical properties like chemical properties, maybe the pH of the soil. That all properties will directly influence the runoff of the soil. If the moisture content is there, definitely it will influence. If the soil is dry, it will influence the runoff. So hydrological soil group is directly influencing the runoff conditions. So in the SCS method, these properties are represented by a hydrological parameter. So the minimum rate of infiltration obtained for a bare soil after the prolonged wetting. So minimum infiltration which is rated for the prolonged a minimum rate of the infiltration obtained for a bare soil after the prolonged wetting of the soil. The influence of both soils, surface conditions, infiltration rate and its horizon are thereby included in this hydrological group. Now antecedent moisture conditions. What is antecedent moisture condition here? So the soil moisture condition in the drainage basins before runoff occurs is another important factor which will influence the final CN value. So in the curve number method, the soil moisture condition is classified, and they are classified into three antecedent moisture conditions. So the three antecedent moisture conditions are: number one, the soil is a drainage basin which is practically dry. Soil in the drainage basin which is practically dry, and that is the soil moisture content is just melting the point. And if you see the AMC 11 or 2, so average conditions of the soils will be there. AMC 3, the soils in the drainage basins are practically saturated from the antecedent rainfall. So this is how it is classified into three antecedent moisture condition, 1, 2 and 3. So in the first condition it is practically dry. In the second one it is average condition. In the third one we can see the basins practically saturated in the antecedent rainfalls. Now runoff coefficient. The second thing here is in this rainfall potential indices we see here is runoff coefficient. So what is runoff coefficient? So the runoff coefficient is the dimensionless numbers. So it's a dimensionless number that represents the fraction of rainfall and that will appear as runoff. So it varies based on the land cover and soil type and the slope. So this will runoff coefficient, it's a dimensionless as a fraction of rainfall. It will appear as a runoff and it varies based on the soil land cover and the soil type and the slope. So what is the slope, what is the soil cover and what type of land cover it is having, based on that the conditions will change. Values typically ranges from 0 to 1. So the values in the coefficient will range from 0 to 1, where the higher values indicate higher runoff. So if it is 1, that means it's a higher runoff. For example, impervious surfaces like concrete have a coefficient close to 1, while forested areas have a lower values. So here 1 we have a close to 1, while forested areas we have a lower values here. Now topographic indices. So what is topographic indices here? The slopes which we have, steeper slopes generally increase the runoff potential, and because water flows more quickly and has less time to infiltrate. So steeper the slopes, the slopes generally it will increase the runoff potential, and because the water flows more quickly and has less time to infiltrate. That's why in topographic conditions, if we see, as I have told you before also in the previous slides, so wherever you see the steep slope, wherever you see the hilly areas, the infiltration rate will be less. So it will get less time to infiltrate. So the quick thing is like the flow is more quickly. From there the water will flow very quickly out of that. Now elevation, higher elevations might receive more precipitations. So in the higher elevations you have more precipitations, they are receiving more rainfall, and that will influence the runoff also. It will influence the runoff also, like higher runoff will be there in the elevation areas, and which will influence the precipitation. So there of course the rainfall is more, the precipitation is more, but the only thing problem here is infiltration influencing will be, precipitation and influence will be less in this region. So flow accumulation, so areas where water coverages tend to have, so where the water coverages they tend to have the runoff, higher runoff potential. So that will be like areas where you have water coverages and it will be having a higher runoff potential, wherever the water is accumulated, so higher runoff potential will be present over there. Now if you talk about the soil hydrologic groups, so in this we have classifications like soil are classified into 4 hydrologic groups, that is A, B, C, D, based on the infiltration rate. So group A is like high infiltration rate, sandy soil. So wherever you see this group A type of soil, where you have a high infiltration rate, where it has low runoff potential and it has a high infiltration, that means the seepage of the water, the holding capacity of these kind of soils is more. So sandy soil is having more holding capacity, water holding capacity, whereas if you talk about the clay soil, it is having less holding capacity. Now in group B, if you see moderate infiltration rate, loamy soils. So loamy soils, like the places where you have this loamy soils, it has a moderate infiltration capacity, where the infiltration will be less and the soils will not be easily, the water will not seep easily. The runoff will be average over there. So it's not like runoff is too high, it's not like runoff is too low. So it's average conditions. Conditions are very average over there, either high or low. Now group C, slow infiltration rates. So clay loams, it has a very slow infiltration rates in the clay loams. So wherever you find the clay loams, means you have very less infiltration. Like if you pour water on the clay soil, it doesn't have the infiltration capacity. The water is not able to absorb the water. So it will, the flow, the runoff is obviously that the runoff is always the more in that condition, and there is a very less chances of holding capacity of the water. Now if you talk about the group D, it's having very slow infiltration rate. Group D is having very slow infiltration rate. It has a high runoff potential, clay soils. So totally runoff areas wherever we find clay soils, when you map the areas where you have these types of soil, so based on the type of soil we can just decide that you can just come to a conclusion that how much will be the runoff. If it is a clay soil, that means the runoff is definitely more. If it is a sandy soil, the runoff is definitely less. So wherever you have a sandy soil, that means the infiltration rate is more. That means the groundwater capacity is more in this such regions. Whereas in the soils where you have the clay soils, there the infiltration will be very less in such regions. So these are all the hydrologic groups of the soil where you can just decide the type of the soil will decide the infiltration rate of the soil or the group of the soil. Now land use and land cover, this we have discussed many times about the land use and land cover. So land use and land cover, as we know that it's like urban and agricultural forest grasslands, which is significantly which will impact the runoff potential, and urban areas with impervious surfaces and have higher runoff potential compared to the natural or the vegetated areas. And wherever you find more vegetation, wherever you find the forest area, the runoff will be less, and the the water holding capacity, the infiltration rate is more in such regions. Whereas in the urban areas, when we find more concrete structures, there the runoff is always more. There is no infiltration rate. So that's why in the urban areas we just come across with this water problems. There is less groundwater table. The groundwater tables goes down, and the problem with the waters will be start happening. Now antecedent moisture conditions. So AMC, antecedent moisture conditions, the moisture content of soil prior to the rainfall event can influence the runoff. So the moisture content which is prior to the rainfall event, that can influence the the runoff soil that is already saturated with it will produce the more runoff than the dry soils. Why it happens is like some of the soils which is near to the water body, so it is having lot of moisture content in that. So it is almost saturated with the water, so it is not having more capacity to hold the water. So in that case the flood can occur, in that case the runoff will occur. So the water, even though if it is a sandy soil, the water, if it falls on the ground, it will not hold the water, because the soil is already saturated. It is not having more capacity to hold the water. So in such areas, the water will flow out of that range, and there is a more chances for the flood activities. So this is how we can just find out the conditions of the areas. And hydraulic conductivity, the ease with which the water can move or through soil pores, or the higher conductivity means the lower runoff potential. This hydraulic conductivity we can show based on this, how much soil is having the pores in that, and how the higher conductivity means the lower runoff. So if it is having low porosity, that means the runoff is more. If it is having high porosity, that means the runoff is less, because it will just infiltrate, the water infiltration will be increasing in such areas. Now vegetation cover. So dense vegetation can reduce the runoff, as I said before also. Wherever you find the dense vegetation, it will reduce the runoff of the water, and it will promote the infiltration and the transpiration rate in such regions. So wherever you have forest areas, if you check the map of the area, if you want to know the water condition of such area, if you see the water quality, if you want to know the water condition, the presence of the water in such area, then you just see the map of that area. If it is having more vegetation, like forest, or if agriculture or any kind of plantation, if it is having more vegetation, that means that area is not having a water problem. The groundwater table is high for such region, and the infiltration rate is also more, because it has a water holding capacity. So if the vegetation is more, that means there is no soil erosion, and there is no runoff from in such areas. So this is how we can just find out the areas where we can just get to know, if you want to know about the water quality and the quantity of the water, we can just get to know. Now models and tools. So what are the models and tools we are going to use? We can use to find out the soil and water assessment. We can just get to know. So we have a tool here, we call it as SWAT. So SWAT is that soil and water assessment tool, which will help us to know, this model will help us to understand about the soil condition and the water condition, and it has a comprehensive model that uses the multiple indices and factors to predict the impact of land management on water, sediments, and agricultural chemical yields in the large complex watersheds. And we have this HEC and HMS hydrologic modeling system. With that, we can just develop by the US Army Corps or the engineers. So this model stimulates the part precipitation and runoff processes in this tool. So this is the one of the SWAT tool which is used in the ArcGIS software. So once you input the data, like input data, if you see, we have input the data DEM. So what is DEM? DEM is the, what is DEM here? DEM is digital elevation model. Okay, DEM is digital elevation model. So once you input the data DEM and you have this hydrography map. So second thing here you have hydrography. So it will show you about the hydrological features like water bodies which are present in that. Then you have a map called as land use. Okay, land use or land cover, you can say. So this map we are having, and we have raw GIS data. So this is the raw data we have in the GIS. So once you along with this, we have a soil data too. So this all data, if you just input in the SWAT is a tool where we can use in the GIS software. We have this tool. So if you input this all maps and just you try to run the analysis process, then finally we get an output of that, and it will tell us about the process. I mean, how much is the runoff of that such area. Like here we have the watershed delineation, HRU delineation we have done, weather station we have just find out, and we have just integrated with this, and finally SWAT database parameterization, editing, calibration, and output tables in charts, and finally we just influence with the SWAT model, and this is done in the ArcGIS software to get the soil and water condition in such areas. Now, what is the conclusion of this potential indices here? So, if you talk about this runoff potential indices, it provides the critical insights into the how watershed is responding to the rainfall. So, conclusion here is by using this types of the indices, we can just come to a conclusion that based on the rainfall, based on the watershed conditions, the rainfall runoff which is going to occur, how it is responding to the rainfall events, and in which areas the rainfall is more and the runoff is more, and is there any chance of flooding of such areas, that we can just come to a conclusion based on this. So they help in planning and managing the water resources. They even help us in planning the resources, manage the resources, and mitigating the flood risk. This will help us in flood mitigation. So what is mitigation here? The term mitigation here is trying to find out about the more technologies, trying to find out about the more advantageous tools which we are going to use to find out the another source, I mean another technology to come out of this disasters, or come out of this losses which we have faced during this flood or drought season. So flood risk zones also we can just find out, and we can mitigate in such regions. That's next time in the coming years the flood will not occur in such regions. And designing the effective stormwater management system in the urban areas, we can just design the stormwater management system, because if you know the rainfall and runoff conditions, how much rainfall is occurring every year, and what is the runoff condition, and what is the type of the soil, if you do this analysis, we can just get to know the total condition of such area. We can get to know that this much rainfall, if it is going to occur, what is the runoff of such area. So if the area comes under the flood risk zone, if the area comes under the drought risk zone, so what conditions we have to take care, how we can manage this. Even stormwater management system we can do wherever the water is flowed and the flood chances are more, the flood risk chances are more. There we can just get mitigate that areas, and we can, whenever the flood has occurred, whenever the storm will occur, we will try to mitigate and we'll try to solve the issue in such issues of such cases, and we can just avoid the losses in such regions, and human loss and property loss can be avoided based on this runoff potential indices, if we get to know about this runoff conditions of such areas. So this was the topic about the runoff indices. So for references, you can just go through this Dr. M. N. G. Reddy book by the BS publication in Delhi. You can just find out the more content on these links to get to know about the runoff conditions, about any area, if it is a watershed area or it is an urban area, or any city, if you have any village, if you have, you can, if you have a small watershed area, if you have a small region where you can just get to know the information based on this all indices practices, the models which you can use like SWOT model we can use, and type of factors which are going to influence that, all we can just use it and we can just get to know about the final output, and we can take a decision for whether you have to plan the city in such a manner or how to manage the water resource of such area. It is very helpful using this GIS and remote sensing in this runoff potential indices. So this was about that runoff potential indices. I hope you understood about this lecture today. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.